record, share screen, this, clear that. Today, oh, I got to pause the video real quick. It's April 4th. It's April 4th, and we begin now the journey into the end of the year. Today's notes are specifically just about polynomials. And you'll get used to that word. Don't worry, polynomials. It refers to a lot of different types of things. Polynomial is a pretty general term. And I used to make the mistake early in my career of talking too much about what a polynomial is. Like, what does it mean to be a polynomial? And I think that that conversation can come up some other time, weeks from now, perhaps, when we're ready to think in those terms. But for now, we're going to look at some examples today of what polynomials look like, and we're going to learn how to classify them. That means to give them names based on their characteristics. And we're also going to learn how to add and subtract them today. So today's, there's a lot of content today, but none of it will be even close to difficult. So polynomials can look a lot of different ways. So let me give you some examples. This is a polynomial. That is a polynomial. That is a polynomial. That is a polynomial. I could go on like this forever, but I certainly would not. That would be weird and unnecessary. So again, rather than discuss the definition of what a polynomial is, just know that there are lots of different types or flavors of polynomials. And the first half of today's lesson is dedicated to learning how to look at a polynomial and classify it by what are called its degree and its number of terms. So let's get some vocabulary out of the way first. So some words that you're going to hear a lot. The first one is degree. And the degree of a polynomial is defined as the highest variable exponent. And there's another classification, and I'm going to hold off on that one just for a second. And let's go back and look at the 5 polynomials on the television. There's blue, red, green, yellow, and white. So when you look at the blue polynomial, what would you say its degree is? It's 3, because its highest variable exponent is right here, x to the 3rd. There is another x in the polynomial, but that one's just x to the 1st. And so we're always going to make our classification based on the highest one that we see. Okay, how about this red one? What's his degree? It's 1, because it's 4k to the power of an invisible 1. We've talked about that he's there. We just don't necessarily want to see him. How about the green guy down here? His degree is 2. Very good. How about the yellow guy? What's his degree?
0.
It is 0. Okay. Because there is an x attached to it that you just don't see, and I'm going to write this. I'll give you a second to make sure your heads are all looking at the TV. I'm going to write something, and then I'm going to erase it, but I just want you to see it. If someone said, I absolutely insist that you put a variable into the yellow polynomial, you could go like this. You could go, okay, I'll put x to the 0th. What did we learn in a previous unit? What is x to the 0th the same as?
1.
It's 1, and negative 12 times 1 is pointless. So there is a power of 0 on an x, but again, we would never in our right mind write it down, right? But we understand that it's there. All right, so that polynomial has a degree of 0. How about the white polynomial off to the right over here? His degree is also 2. Okay, so do you understand that it's not the term that's in front or anything like that? It's just we find the variables in our polynomial And whichever variable term has the highest exponent, that exponent will define what we call the degree of the polynomial. The other way we classify a polynomial is by its number of terms. And I actually don't even think that that's something that you need to define. The only thing we need to really talk about here is what is a term. And so a term, let me come back up to the blue polynomial. I'm going to show you what a term is. And it's one of those things like you've used the expression combined like terms thousands, if not hundreds, maybe thousands of times. But the terms themselves, you have to understand, are the chunks of stuff that are separated by plus and minus signs. And so like x to the third is a term, negative 4x is a term, and positive 5 is a term. I'm trying to use shapes for your educational convenience there. So we would say that that polynomial has 3 terms, right? How many polynomial, or how many terms does the red polynomial over here have? How about the green one? How about the yellow one? And how about the white one? Good. So let's get to it. Now that you understand the kind of the vocabulary here, we're going to throw some words out here, and we're going to learn to classify polynomials. So when we classify a polynomial, we classify it first by its degree and then by its number of terms. You guys haven't taken geometry yet. Have you ever classified triangles? Have you ever heard someone call a triangle like an acute isosceles triangle? You ever heard that? Or an obtuse scalene triangle? Are you familiar with all those words? So it's classifying a polynomial kind of feels the same. When it comes to triangles, you pick a word from the angle bag, and the angle bag is either acute, obtuse, or right. You choose one of those 3 words. And then from the side bag, you either choose scalene if none of the sides are the same, isosceles if 2 of the sides are the same, and equilateral if all, you know what I'm talking about, right? It's like you pick a word from this bag, pick a word from this bag, and that's how you classify a triangle. The same thinking applies to polynomials. So let's learn our words. And today is the last day that we explicitly talk about this as a lesson. Tomorrow, I assume you know your words and we just press on from there. So the first thing we talk about is degree. And if the degree of a polynomial is 0, we call it a constant. Which actually should make sense already, because if you were to go back up to the notes, I mean, it's on the TV, but it's not actually there right now. But if I scroll back up to the yellow one, the one polynomial on the board that had a degree of 0 was this yellow one. Do you see why we would call that a constant? What does it mean for something to be constant? It never changes. And if there's no variable in it, it never has a chance to change what it is. Negative 12 is just negative 12. It constantly is negative 12. Hence the term constant. So if there are no variables, the degree is 0, and we say that the polynomial is a constant. I don't know if you've ever heard these words before, not in this context, but I'm going to ask anyways. Does anyone know what a first degree polynomial is called? You did a whole bunch with first degree polynomials this year so far. Remember when we graphed straight lines? We called those graphing linear equations. I don't know if you recall that or not, but the reason they're linear is because the x's that we had were x to the first power. I had you graphing like y equals 4x minus 2, y equals 1/3 of x minus 9. Those are all linear functions because x is to the first power. This next one is the one where I can say, welcome to the next 6 weeks of your life. Degree of 2, you've heard me use the term before. What did you say? I know, and you got a good memory. You said something hilariously wrong, but it's nicely sort of on point. A quadrilateral is a 4-sided polygon. The word you keep hearing me use is quadratic. So, I mean, when I heard you say quad, I thought, excellent memory. Yes, I've been using this word. I've been trying to kind of sprinkle it in at various opportunities, but quadratics, you're going to want to probably put a little star by this one. This is going to be basically the rest of the year. It's working with quadratics. Okay. We also have a name for third degree polynomials. Yeah, maybe not this year, but yes, we will. Yeah, probably not until May when the time comes. But yeah, eventually we will learn the quadratic formula song, and you don't have to sing it. Yes, it's sung to the tune of "Pop Goes the Weasel." Don't worry, you'll learn it. You don't have to sing it. I always hated as a kid, like as an adult, I hate forced group participation. I was the kind of kid in school who was just, let me sit here, I'll do well on your tests and I'll do your work, but please don't make me do stupid things. And singing a song, I think, qualifies as a stupid thing. So rest assured, I'll never make you sing the song, but some people really enjoy it. So, and it really does help. It helps to remember the quadratic formula, but we're weeks and weeks away from that. So anyhow, a third degree polynomial has a name. It's called a cubic. A fourth degree also has a name. Anyone want to take a shot? It's no logical. No. It's called a quartic. You do need to know these words, and I don't do a lot with holding you accountable for vocabulary, but in this case, you do need to know your terms. And there's one more word that we use, and it's for fifth degree. Well, we'll get there when we get there. Fifth degree polynomial is referred to as a quintic. And there are words for these, and you're welcome to Google them. If you find like a Wikipedia or a math page, there are names. I believe 6 is like a hexic, and then there's like heptic, octic, nonic, decic, and you could keep going. But we don't. Math people have all kind of agreed. We don't see a lot of polynomials in practical mathematics, quite frankly, past the fifth degree. So we stop naming or giving a hoot about what to call them after fifth. So for 6, we just call it a sixth degree. Pretty kind of a little bit of a letdown there. And then you can imagine like 7 is seventh degree and so on and so forth. So like I said, if you would like to go further and learn the words, you're welcome to do that. Just don't do it right in the middle of the lesson. But so you need to know constant through quintic. So constant, linear, quadratic, cubic, quartic, quintic, and then after that we just throw in the towel and call it sixth degree, seventh degree, 10th degree, 12th degree, whatever the case may be. Okay. Now for your second batch of words, we also have to define a polynomial by its number of terms. If a polynomial has one term, it's called a monomial. Absolutely. I couldn't agree more. And if that makes sense, like Shariah said, because mono means one, then you probably already know what a two-term polynomial is called. Nope. Very good. It's a binomial. And we don't make you learn these words because we like to torture you. It just makes the daily goings on and our interactions more functional. Like we just get along better, and we flow through the math course better when we can say words like, "Hey, write me a quadratic trinomial." Then we don't have to stop and talk about it all the time. So I just said it, and obviously you would have figured this out. Polly just. The only ones that we have names for when it comes to number of terms are 1, 2, and 3. And kind of like how we bailed out after quintic when it came to degree, we bail out after 3 when it comes to number of terms. So if it's a 4-term polynomial, we just say it has 4 terms. I mean, again, it's kind of a letdown, but maybe draw a line in your notes there as if to signify, okay, after this point, I just kind of chicken out and call it generically what it is. You may not call a two-term polynomial a two-term. You must call it a binomial. 3 has to be a trinomial. Like a 4th degree has to be a quartic. But you use the bailout terms when we go past our maximum thresholds. So I'm going to put a polynomial up here on the board, and you're going to help me classify it. So we're going to go with 5 minus 4x squared plus 2x minus x to the 4th. See a lot of you writing this down. I appreciate you for that. Good notes. What's its degree?
4.
So we have a name for it. We call it a quartic. How many terms does it have?
4.
Good. So we call it a quartic with 4 terms. Okay. Let me switch colors here and let's go again. Let's go with 10 plus x cubed. What's its degree? And how many terms? So what would we call it? A cubic binomial. Cubic coming from the fact that his degree is 3. Binomial coming from the fact that it's got 2 terms. Okay, let's go again. There's your polynomial, 8. Very good. You guys got the words. It seems like you've picked this up relatively quickly. This is good. Constant monomial. You'll never see a constant binomial because someone like me will tell you that you need to combine your constant terms to make a constant monomial. So constant binomials don't really exist, not in a practical sense. Okay, so far? All right, the next piece of our notes, we need to learn something muy importante, and that is called standard form. And for your notes, what you need to know about standard form is that we always want to write our polynomials as in a particular order, where the degrees go from highest to lowest. So you always want the most powerful term to lead the way, and then we're going to staircase our way down to the lowest degree term. So for example, let's say I gave you a polynomial like 5 minus 8x squared plus 2x. First off, let's classify it real quick. What would you say real quickly is his classification? He's a quadratic trinomial. Yeah, you're going to see hundreds of those before we part ways for the summer. Quadratic trinomials are pretty huge. Which term has the highest degree? The -8 does. And so we're going to take this term and we're going to put it in front. -8x squared. And then who comes in second place? The 2x. The linear term would go next. So the quadratic term led the way. The linear term of plus 2x comes in second. And then, of course, taking up the caboose position is the constant, in this case, plus 5. And we have to put a plus on the 5 because it was a positive 5 to begin with. There's an entire side of your worksheet today dedicated to this. Write each polynomial in standard form and then classify it by its degree and number of terms. You think you can handle that? Okay. So again, what is standard form? Rewriting it how? Yeah, don't answer my question by repeating what I asked you. What is standard form? Yes. Greatest to least for your exponents. Good way to say that. All right, the second half of today's lesson deals with adding and subtracting polynomials. We will stay away from multiplying for probably one more day, and then the multiplication will take over. So today we learn about adding and subtracting polynomials. You can add and subtract polynomials regardless of what flavors they are. Like you could take a quartic binomial and add it to a cubic trinomial, or you could take a constant monomial and subtract it from a quadratic binomial. It doesn't matter. There are no rules. There will be when we do matrices in a couple of years. But for now, there's no rules about this. And so I'm going to take a polynomial. Let's do it this way. Seth, will you write me, just say out loud, a quadratic trinomial? Quadratic trinomial. You just started to read me a quartic. Mm-hmm. You're fine.
5x to the second.
There you go. Okay, and I am going to fix that in a moment, but I appreciate it. It's a really nice quadratic trinomial. It's quadratic because of the x squared. It's a trinomial because it's got 3 terms. And I'm going to put a plus sign here. Erica, will you give me another quadratic trinomial? Anything is fine. I like that. That's a wonderful quadratic trinomial. And quite frankly, with what I'm about to ask you to do, I don't have to fix Seth's out of order polynomial, but I feel like if we're going to do this, let's make it nice and clean. So I'm going to take this 5x squared plus 2 plus x, and I'm going to rearrange the plus 2 and the plus x so that Seth's is in standard form, just like Erica's is. Now, prepare to learn one of the easiest things that you've learned all year, and that is how to add 2 polynomials together. Adding polynomials together is as simple as just combining the like terms that you see. So if you take the x squareds and you put them together, what is 5x squared plus 7x squared? 12x squared. And you're going to run into some dilemmas over the years about like, when do I change the exponent, when do I not? But I think of x squared as like a physical thing. You'd call it a cookie. If you have 5 cookies and someone brings you 7 more cookies, the cookies don't change into like power cookies, right? They don't become super cookies. You still just have 12 cookies, right? So we do not change the exponents when we're adding things together. We merely just manipulate the numbers in front. How many x's will we get?
4.
Very good. And then what's our constant term at the end going to be? Very good. So that's how we add a couple of polynomials together. All right, let's do it again. This time I'm going to write them just so it goes a little bit quicker. So we're going to do negative 4x cubed minus 2x squared minus 11x plus 15. And we're going to add negative 3x squared plus 11x minus 15. So we are adding a cubic 4-term polynomial to a quadratic trinomial, and it's okay. We're just going to go through and we're going to find all the terms that can go together, and well, by God, we're going to put them together. When you do this, you always want to start with your highest degrees first. If you know that that's how your answer is supposed to go, then you should start there anyways. So how many, what's my leading term, my first term going to be? This guy that I'm pointing at with these arrows, does he have anyone anywhere along the line to go with? Then he will just be the leading term, we say, in our answer. Now I'm going to color code for you. I do see some like terms right here. I see a quadratic term, and right here I see a quadratic term. How many net total will that be? Negative 5. X squared. Remember, don't change what they are, just change how many of them you have. And then that takes us to the linear terms, and that's a negative 11x here and a positive 11x here. So there are no linear terms in my answer. They just cancel each other out. Exactly. And the same thing happens with our constant terms. Very good. And so this 15 and this minus 15 cancel. And so our answer is a cubic binomial. Now, there's one more part to this lesson, and I hope that you trust me enough to believe what I tell you about this. It's not going to seem like it should be any more difficult than this, but I look at like that problem we just did. You give that to 100 kids, 2 might miss it. What we're about to do is going to look just the same, and it goes all the way up to like 40. And I think it's generally because people think their math teachers are crazy, and they're like, yeah, I don't trust that guy. So what we're going to do now is we're going to subtract polynomials. And it doesn't seem like it ought to be a big deal, but I don't know, man. So let's do 4x squared plus 5x minus 19 minus 10x squared minus 6x minus 4. 1 minute from now, there will be 2 groups of you in this room. There will be people who trust me and do exactly as I say, and there will be people who say, no, I don't need to. I know more than this quack in the tie. So I hope you pick the first group. My experience tells me that if we're willing to show a little bit of work in this problem, we'll do fine. We'll get it right. But the issue here is that there's a minus in front of a set of parentheses. This guy right here. You change the signs of all the things that come after it. That's the way a minus, it's called distributing a negative. You've seen it before. When you distribute a negative, it doesn't just change the 10x squared, it also changes the 6x and the 4. So my advice to you, you can take it or you can leave it, is to rewrite the problems when they're subtraction. And I didn't have to do this with plus. Plus is stupid. Plus is easy. Take this advice or leave it. I'm going to rewrite this problem. This 4x squared plus 5x minus 19. What is 10x squared going to change into? Minus 10x squared. What is minus 6x going to change into? And what's minus 4 going to change into? Bear in mind, I've been doing this year, my 26th year of teaching, and I would not take something like this and slow down and get all bossy with you if I didn't really believe in my heart that you should, and you should. Something about minus, man. But if you take that negative and distribute it and show your work, it takes like 10 seconds. You show your work, and then you could just go combine your like terms because they're right there in front of you now. So how many quadratics are we going to get? What's our quadratic term going to say? No, I don't think so. 4 minus 10 is definitely negative 6. So we have negative 6x squared. We call that the leading term. What's my constant, or excuse me, my linear term going to be? Good job, you guys. And I'm going to keep using those words until we all just kind of start using them together. And then my constant term is going to be what? Negative 15. Nice job. Got it? Feel like you're good? Okay, I'm going to end the recording and hand out your worksheet. I don't know how long it will take. We will